Welcome back, everyone, to the channel. So, transistors are pretty important, but did you know that like 99.9% of all the transistors you see are MOSFETs?
Yeah, it's pretty crazy how one type of transistor has become so common.
To understand that, we kind of have to go back to the basics. What is a transistor, and why are they so important in electronics?
Well, a transistor is basically a tiny semiconductor device. It can amplify or switch electronic signals and power, and they're like the basic building block of almost all modern electronics.
Smartphones, computers, you name it.
Exactly.
And they've come a long way. You can trace them back to 1947.
With the point contact transistor.
That was a huge deal for making electronics smaller.
And then came the MOSFET.
Between 1955 and 1960.
And that really changed the game.
Yeah, the MOSFET was a total game changer.
Yeah.
But to really understand it, we need to know the different types of transistors and how they work.
Right. There are two main categories: bipolar junction transistors, or BJTs, and field effect transistors.
Let's start with BJTs. Can you explain how they're structured and how they control current?
Sure. A BJT has three terminals called the base, the collector, and the emitter. Think of it like a valve. A small current at the base controls a much larger current that flows between the collector and the emitter.
So it's the base current that controls the larger current flow.
Exactly. And this ability to amplify signals is what makes BJTs so useful in things like audio amplifiers.
So how do FETs differ?
Well, unlike BJTs, FETs use voltage to control the current. They also have three terminals: the gate, the source, and the drain. And the voltage applied to the gate is what controls the current flow between the source and the drain.
You could compare it to a dam controlling the flow of water.
That's a good analogy.
So BJTs are current controlled and FETs are voltage controlled. That's a pretty big difference. Where does the MOSFET fit into all of this?
So the MOSFET is a type of FET, and it's so popular because of its insulated gate. This insulation means it draws very little current from the control circuit, making it super power efficient. And that's really important these days with all our portable devices.
Yeah, we all want longer battery life. And we know transistors amplify signals, but they also act as switches, right? Especially in digital circuits.
Absolutely. In digital circuits, transistors act like tiny electronic switches that flip on and off super fast. They're basically the foundation for how computers process information. And they're not only in digital circuits, transistors are crucial for all sorts of applications where we need to amplify signals.
Yeah, like audio amplifiers.
Exactly. Over the years, we've gone from small, low-power amplifiers to the really sophisticated high-power amplifiers we use today in everything from home stereos to massive concert sound systems. It's incredible how engineers have pushed the limits of transistor technology to make it work in all these different areas. And speaking of pushing limits, let's go a little deeper into how BJTs and FETs actually control current, like at the atomic level.
Okay, so what's going on inside a BJT that lets a small base current control a much bigger current between the collector and the emitter?
Well, at the heart of a BJT are two PN junctions.
PN junctions.
Yeah, each PN junction is formed when you have a P-type semiconductor, which has lots of holes, or positive charge carriers, and an N-type semiconductor, which has an abundance of electrons. And when these two meet, they create a depletion region at the junction.
A depletion region.
Right. It's a zone with very few free charge carriers.
So it's like positive and negative charges kind of facing off, creating a neutral zone.
Yeah, that's a good way to think about it. Now, in a BJT, you have two of these junctions: the base emitter junction and the base collector junction. And by applying a small current to the base, we can actually change the width of these depletion regions.
And that controls the flow of current between the collector and emitter.
Exactly.
So the base current is like a gatekeeper controlling the path for the larger current to flow. That's how it achieves amplification.
You got it?
Now how about FETs? How do they control current?
FETs are different. Instead of using current to manipulate these depletion regions, they use an electric field.
An electric field.
Yeah, it's created by the gate voltage. So you have this conducting channel between the source and drain terminals. And the gate is insulated from this channel by a thin oxide layer.
So the gate doesn't directly put current into the channel like the base in a BJT does.
Right. It works through an electric field. So when you apply a voltage to the gate, it creates this electric field that either pulls in or pushes away charge carriers in the channel.
So it changes how well the channel conducts electricity.
Yeah, and that's how it controls the current flow between the source and the drain.
Almost like using a magnet to move iron filings around.
Exactly. The gate voltage is like the magnet, and the charge carriers or the iron filings. It's amazing how these basic concepts can be used to build such complicated electronics.
Yeah, it really is.
And it's this difference in how they work that gives BJTs and FETs their strengths and weaknesses, making them good for different things. Like BJTs are great when you need a lot of current gain, but FETs are better for their high input impedance and power efficiency.
And of course, the MOSFET, with its insulated gate and tiny size, is like the king in most modern electronics.
Exactly.
I'm curious about how MOSFETs have changed specific technologies. Can you give some examples of how their unique properties have shaped electronics as we know it?
Oh, absolutely. Their efficiency has been huge for portable electronics.
Like smartphones.
Yeah, imagine trying to power those with big, power-hungry BJTs. It just wouldn't work. MOSFETs have made it possible to have powerful devices that don't drain your battery in an hour.
They've also been key to making electronics smaller, right?
Oh yeah, definitely. MOSFETs can be made incredibly small, which has helped keep Moore's law going. You know that idea that the number of transistors on a chip doubles every 2 years?
Yeah, that's led to a huge increase in computing power.
Exactly, and it's not just about fitting more transistors on a chip, it's about making them use less power and run faster.
It's crazy to think how these tiny things have led to such big changes in technology, but we're kind of reaching the limits of how small we can make transistors. What do you think the future holds for them?
That's a great question. You know, silicon has been the main material for transistors, but researchers are looking into new materials like graphene and carbon nanotubes.
I've heard of those. They sound pretty futuristic.
Yeah, they could lead to even better performance and even smaller devices.
Wow, another revolution in transistor tech.
Another exciting area is 3D transistors. Most transistors now are flat laid out on a chip in a single layer. But what if we stacked them vertically?
In 3D.
Yeah, that could give us even more density and performance and help get around some of the problems with the old flat designs.
That sounds like a huge step forward. It seems like the future of transistors is full of possibilities.
Absolutely. And these new developments will impact everything from artificial intelligence and machine learning to biotech and renewable energy. Transistors will continue to be at the heart of all this for a long time to come.
Thinking about the different types of transistors, I'm curious about when you'd actually use one over the other. Could you go a bit deeper into when you might choose a BJT versus a FET?
Of course. So both BJTs and FETs amplify and switch, but they're better at different things. BJTs, for example, are really good when you need a lot of current gain.
Okay, so like in audio amplifiers.
Exactly, or like power supplies that need to handle a lot of current. And their lower input impedance compared to FETs can be useful in some circuit designs.
So if you need to move a lot of current, a BJT is the way to go. What about when a FET would be better?
FETs are great when you need to amplify really weak signals without messing up the source.
Because of their high input impedance.
Exactly. And they're also super power efficient, which makes them perfect for anything that runs on batteries.
Like our phones and laptops.
Exactly. It's no surprise that they're everywhere in portable devices.
And MOSFETs are the kings of the FET world because they're so small and have that insulated gate.
Absolutely. MOSFETs are incredibly versatile. So we've only just scratched the surface here.
Yeah.
But I hope this discussion has given you a better appreciation
For these tiny but powerful devices.
that shape our modern world.
They really are the building blocks of so much of our technology.
Remember, we're AI experts,
Right.
giving you an overview of this topic.
And don't forget to like this video.
And subscribe to our channel for more videos. Thanks for watching.
See you next time.